My name is Oleksii, and today I'm going to share with you some of my experience working on infrastructure transformation project. Uh, it's really about planning and estimating activities, also visioning a new infrastructure platform. So let's start. So first of all, I want to tell you about what company we have for this project. So this is a multi-brand retail company that operates on US and European markets. So it has variety of applications and services. Each every brand uh, have their own way of doing SDLC, own culture, all own processes, as well as own set of tools. So we have different approaches to SDLC across brands and wide tools landscape. And basically that lead us to low integration level and almost no consistency between the processes and approaches. And that leads to hard to manage everything. So here's a current tool set, the major parts of that. So as you can see, there's a lot of good brands here. However, they have low integration, low uh, consistency, say, and we cannot trace changes and have visibility across all our application lifecycle. So for that purpose, the idea is to have new ILM platform that will use some trends that here stay for long, that will be flexible enough for the future opportunities for the new way of doing things, new applications. And we want to use some trusted vendors that proven to be reliable and also can handle market needs. So why we're doing that? To support our future grow, and uh, that's why we need the agile infrastructure with optimized ALM toolset. But again, ALM stands for Application Lifecycle Management for its development part to retirement. So we want to introduce ALM standards as a platform to reduce management efforts and cost of ownership of that platform. Also introduce tools and practices to streamline digital service delivery. How we do that? So we will build new cloud-based platform that will support infrastructure as a code, GitOps, Zero Trust practices. Okay, to create all of that, the first we start from is a DevOps strategy. So, and here's three basic terms that will describe that strategy. So, modern infrastructure, shared LM platform to simplify end-to-end delivery process. So, consolidate system landscape and use the single delivery platform for all the services and web applications. And of course, transform the way we do businesses and way we do our development, introducing DevOps culture into our teams. So for that reason, we define several focus areas. So that will be backlog management, static code analysis, source control management, configuration management and infrastructure as a code, tests management, continuous integration, artifact management, release management, and application platform. To start building new one, of course, we need to see what we have currently. So we created as is and to be state. So look into as is state, we can see that the tool set is quite similar across our 5 brand example. In reality, there is 5 more brands. And we can see that they use their system, they use it quite a lot and sometimes even efficient. However, there is no ability to connect or integrate all the systems with making no really huge efforts. So to be state would be mostly Azure DevOps, market leaders for the infrastructure as a code, and will look like this. So we have Azure representing here with web apps and Kubernetes cluster. We have SonarQube and Terraform to support that, and of course Azure DevOps. Why Azure DevOps? So it's already integrated system. So it's ALM platform by itself. It has a sort of required tool set out of the box. So it shares one licensing and cost model that's very convenient. So it has traceability we need out of the box, dashboards, test case management, integration, and all that parts. So we definitely need all of that and can think of making the platform basically for the 2 reasons. So our application, it's mostly web applications and some web services. So they can host on web apps and services can be hosted on the Kubernetes cluster. Okay. So as we defined what do we want and what we want to achieve, let's think about what and how to do that and what would be first. To make a decision on that, first of all, we need to form our goals. So the goals for this project are ensuring major things like ensuring system security, ensuring system stability, ensuring system quality. And we want to create infrastructure that can resist failures. To achieve that goals, we can stop several more technical milestones that will lead us to that goals. For example, traceability from the PBI to the deployed application, deployed code. So that will give us ability to quickly quickly work on some bugs or some additional features or some defects. So we want environment to be consistent and maintainable. So we want support auto scaling for the purpose of testing and cost reduction. Um, Also, we want to consolidate the feedback and make it more automatic as possible. So quality gates, security checks, pull requests, and all the things. Okay, after having that milestones, so we organize it into several tracks. So it'll be source control management, CI/CD, backlog management, monitoring, testing, and basically infrastructure platform. Now we need to estimate these blocks to understand what and what terms we need to achieve that. So to estimating, we have our own scale, relative scale, where we estimated complexity and value uh, every stream gives us. Also, we have a effort that is height and the side of the bubbles. So here we can see that, for example, migrating source control, it gives quite good value, but it's not very complex and not very big effort to make it. So backlog management, more effort, yeah, and more complex, but basically gives us the same value. Yeah. And so things like CI/CD, they're small things, basically not much to do there comparing with testing. However, they gives us very significant value. Um, so at the top, we see lots of infrastructure stuff like replatforming we have to do uh, for our applications. So infrastructure as a code that should be introduced, operation costs, and configuration management. And the most valuable, but also the biggest things is testing and also the monitoring. So how it was estimated and how the data was collected. So we have our relative scale for value, complexity, and effort. So for example, the same source control management, considering here the migration of the source control management. So it's not much effort, but it's quite simple. It's not very complex. So complexity, it's more like what people's skills we need to do that. And effort, basically how hard they should work and how long they should work to to achieve that. And the value, that's a relative value for that item. Yeah. So the same for infrastructure part, same for quality, same for CI/CD. Okay. So after making that kind of estimation, we was able to put everything to the timeline. So at the top, you can see the source control migrations. It's quite simple tasks. And there on the bottom, we have testing. What is more interesting here, that we are able to map our our milestones to that items. So that basically means that if you have migrated source control, migrated big backlogs, and you migrate the release pipeline with the artifact storage, you can have the traceability from your deployed code to your product backlog item. The same for environment consistency. So you need infrastructure as a code and configuration management to make sure that you are consistent. So for after scaling, you need some monitoring. You need to change the platform and of course infrastructure as a code to support that. So feedback requires almost everything we have here for the CI/CD and some basic test activities, at least unit tests and integration tests. So that basically leads us to our goal. So to ensure the system is secure, we should have everything in the CI/CD, static code analysis, and also we can do penetration testing to ensure our system is secure enough. So resistance to failure. So in that case, we need to monitor behaviors of a system. We need to build the infrastructure that basically support that resiliency, and we can prove that using house testing or destructive testing in production. So stability from the same. So we need almost all kind of tests and behavior monitoring. We can say that our system is stable, and our monitoring will prove that. Then quality, of course, with the feedback and tests. Okay, so that was all for today for me, and thank you for watching.